Good afternoon, guys and girls. Today we're going to be comparing and ordering decimals. This is lesson 3-3, and this is what we will be doing our assignment over tomorrow. Let's go ahead and get started. When, first of all, will we ever do this in our real world setting? Well, let's take a look at maybe a McDonald's menu. Now, we can make many comparisons using the prices that we find at McDonald's, and I think a lot of them have changed since what you see here on the slide. I could make comparisons between prices on my menu. I could actually add things up, which we will do later on within the chapter, or I could order my prices from least to greatest or greatest to least by using the place value of my decimals. So this is the concepts that we're going to be working on today. What I'd like for you to do is I'll give you a second, and maybe you could also pause the video. I would like for you to order these items at McDonald's from least to greatest according to the prices that you see here on the slide. So if we order up least expensive to most expensive, we would see that the ice cream cone was the least expensive at 87 cents, followed by the double cheeseburger at 99 cents, small soft drink at 99 cents. You could have had those flipped around and that would have been okay. The McFlurry would be the next at $1.97. The 2 cheeseburger meal at $3.70. The Chicken McNuggets meal at $3.80. The Big Mac value meal at $4.79. And then the chicken salad at $4.80. The most important thing that you're going to need to remember today is that when you're comparing decimals or even ordering decimals, you have to look at its place value. It's very important to line up the decimals whenever we're comparing. So, what do I mean by compare decimals? Well, when we compare, we're going to use such terms as less than with the less than symbol, greater than and the greater than symbol, or equal to with the equal sign. And when we compare decimals, we're going to try to remember back to when we compared whole numbers because it's very, very similar. We start with the largest place value on the left and we work our way over to the right. So for an example, 45 would be less than 47 and 150 is greater than 105. And when we compare decimals, we could use place value or a number line. So you see a place value chart here. To the left of the decimal is our whole numbers, ones through thousands. And to the right of our decimal point are our parts of a whole, our decimals, our tenths through thousandths. So let's use some half pipe results. There were 5 students that competed in the half pipe, and here's their scores. We want to compare Sarah's score with Danny's score. So first things first, we're going to line up the decimal points. Next, we're going to start at the left and find the first place where the digits differ. So we're going to compare those digits. So if we start to the very left in the tens place, we notice that the 4 is the same. We move to the next place value, which would be the ones place. And notice that on Sarah and Danny's score, the 2 is the same. So we're going to move to the other side of the decimal point and we're going to compare tenths. So if we look at Sarah's score in the tenths place, there's a 1, and Danny has a 5 in the tenths place. So we're going to compare the 1 to 5, and we know that 1 is less than 5. So Sarah's score at 42.1 would be less than 42.5, which would mean that Sarah's score was lower than or less than Danny's score. Now, if we use a number line here and look at the number line on the right, and we start at 42.0, each hash mark would be a tenth. So Sarah's score at 42.1 would be on the first hash mark after 42. And Danny's score of 42.5 would be 5 tenths away from 42. So using the number line, we can see that numbers that are to the right are greater than numbers to the left. And since 42.5, Danny's score, is to the right of 42.1, we know that 42.5 is greater than 42.1. Now, there's something else called equivalent decimals. Decimals that name the same number are called equivalent decimals. That means they're equal, such as 0.60 and 0.6. Are these two numbers the same? Well, if we look at a picture of a grid, on the left you see a hundreds grid, and we see 60 square boxes filled in for 6 hundredths. But if you look over on the right, if we just did our tenth strips, you'll notice that it takes up the same amount of space. 6 tenths, 6 hundredths. Well, if we notice the sixth is in the same position on both decimals, our decimal is the same, it's equivalent. They've just added a 0 after our 6. If we added a 0 after our 6 here, or 5 zeros, they would still be the same number. Those are equivalent decimals. Now there's something called annexing zeros, and this will help you when you place a 0 to the right of the last digit in a decimal. So again, for instance, if we take our decimal from the last slide, 0.6, and we annex a 0 on the end, even when we add a 0, our 6 in the tenths place is still the same. It's still equal. We could add hundreds of zeros after our 6, and it would still be the same number. Although we've added a 0, the value of the decimal does not change. So annexing or adding zeros is useful when ordering a group of decimals. It holds its place value. It makes it easier for you to order. So we can order decimals from least to greatest or from greatest to least. So let's look at our example. Go ahead and write these numbers down in your math journal. 15, 14.95, 15.8, and 15.01 from least to greatest. Now would be a good time to pause your video for a second in order to write those numbers down. So if we follow those steps with our numbers that we had on the last slide, we're going to first of all line up our decimal points. And even though we have a whole number of 15, we can assume that this number is 15.0. So we're going to line up our decimal points. Next, we're going to annex 0 so that each number has the same number of decimal places. So our largest number that we have has the hundredths place. So our numbers that have the tenths place or a whole number, we want to annex 0 so they're all the same. Finally, we're going to use the place value to compare the decimals. Always start from the left. So since we have numbers that are in the tens place, we're going to start with our 1. And all 4 of our numbers start with a 1, so we're going to move to the ones place. I have 3 numbers that have a 5 in the ones place, and then this number right here, 14.95, there's a 4 in the ones place. So I bet this number is going to go first. So we line them up again, and that 14.95, when we order them, it's probably going to be the first number. 15 would come next, 15.01, and then 15.8. Those would be the 4 numbers in order from least to greatest. Now you have one more time to put one more example into your math journal. We're going to order these numbers from greatest to least. I have 35.06, 35.7, 35.5, and 35.849. What I'd like for you to do is I would like for you to use those strategies that we just talked about in the video And tomorrow when you come in, I would like to see in your math journal these 4 numbers ordered from greatest to least. Now, if you have questions about comparing decimals or ordering decimals, make sure that you, 1, either write it in your math journal and ask those questions tomorrow, or 2, post your question on Edmodo this evening, and I can answer your question, or if there's other students online, they can answer the questions for you as well. But again, tomorrow when you come in, I would like to see in your math journal these 4 numbers ordered from greatest to least. Have a good evening.